Hello, this is Mark from Excel Off the Grid. In this video and the next few videos we're going to cover the topic of dynamic arrays. But before we start, I suggest you subscribe and get notifications so that you don't miss any of the future videos. Okay, if you're ready, let's get started. See, the truth is that Excel has changed, like seriously changed. Every time we used Excel in the past, we accepted a simple operating rule: one formula, one cell. Even with advanced formulas, it was still necessary to have a cell for each of them. But this has changed. Now Excel allows a single formula to fill multiple cells. And this is possible because Microsoft has changed Excel's calculation engine to allow something called dynamic arrays. Now the term dynamic arrays sounds complicated, but once you understand it, you'll appreciate the simplicity and the power. Let's start with an overview of dynamic arrays, and we're going to begin by looking at a very basic example. Here's a formula. The formula is equals, and I'm going to select cells B2 to B6. Okay, it's probably not a formula you've ever used, but it's simple enough for us to describe the impact of dynamic arrays. You see, in the old version of Excel, only one cell result could be returned. So if we provided a formula like we have here with many cells, B2 to B6, then some assumptions need to be made. And in this example, there are actually two possible results. So I'm going to press enter here and we'll see what happens. And in the old version of Excel, we would see a value of 1. And that is because the formula is in line with the source data. So we've asked for cells B2 to B6 and we've put it into cell D2. So therefore it will return the value in cell B2 because it's in line. If we were to apply the same again in cell D4, put equals, select the cells B2 to B6 and press enter. There you see we have the value of 3, and that's again the same principle. We've given it a range of cells and Excel assumes that we want the cell that's from the same row. Okay, what happens if we use the formula when it's not in line with any of our source data? So let's move down here to cell D7 and we'll type in the same formula again. Equals, and we'll select the cells B2 to B6 and I'll press enter. Now this time instead we get the hash value error. And that's because Excel gets confused. It doesn't know which cell we want to return the value from. We've given it a range, but it doesn't know which cell we should use because it's applying the principle of one formula, one cell. So the assumption that Excel makes here when we provide a range into a single cell has got a name, and that name is implicit intersection. But thankfully, you don't need to worry about that anymore. But it's interesting to think that Excel could calculate different results from the same formula. It could calculate a 1 or a 3 or a hash value as we've seen there. Equally, it could have calculated 2 or 4 or 5 depending on which cell we put our formula into. Now in the past, Excel allowed us to override this implicit intersection method by using Control, Shift and Enter when we entered a formula. So let's have a quick look at that. Here's our formula, and when I press Control, Shift and Enter, as you can see it returns the value of 1. That's because Excel now understands that we don't want to use implicit intersection, but actually we want to use the first cell in that range. If I were to delete that and then select 5 cells, and then type equals, and then select our range B2 to B6, and then press Control Shift Enter, what Excel would do is it would understand that we have an array of values. So in the first cell we want to return the first value. In the second cell of that array we want to return the second value, and in the third cell the third value, etc, etc. But with all of this we had to press Control, Shift and Enter to make this work. Well, we don't need to worry about that anymore, because if we have a newer version of Excel that has dynamic arrays enabled, then actually this formula that we have here, equals B2 to B6, only has one possible result. So let's try that out. Here we have another worksheet, and in cell D2 I'm going to type equals, put B2 to B6 and press enter. And as you can see, this one formula equals B2 to B6, Excel has taken that and spilled the results into the cells around it. So that one formula now fills 5 cells. Now, that's pretty amazing because the basic rule of one formula, one cell has gone. Now, the terminology to describe how this happens is known as spilling, and the range of cells that are filled by the formula is called the spill range. Now, this may not seem like much, but as we go through the rest of this video, I hope you'll soon appreciate the power that this really gives us. So you're probably asking, which versions of Excel have dynamic arrays? Microsoft originally announced the change to Excel's calculation engine in September 2018, and for over a year it was only available to those who signed up to test early releases of the new features. And that's part of what's now called the Microsoft 365 beta channel. Regular subscribers on the Microsoft 365 monthly update channel started to receive this update around November 2019. And finally, in July 2020, those on this semi-annual update channel of the Microsoft 365 subscription, which is mostly business users, also started to receive dynamic arrays. Microsoft have already confirmed that this new functionality will not be available in Excel 2019 or prior versions. So if you want it, then unfortunately, it's time to upgrade to a Microsoft 365 license. When Microsoft announced dynamic arrays, they also introduced 6 new functions, all of which make use of this new functionality. There's unique, sort, sort by, filter, sequence and rand array. While we all get excited by new functions, the introduction of dynamic arrays is much bigger than just these functions. It's a fundamental shift in how Excel and Excel users think about formulas. In the remainder of this post, I want to show you the basics that you need to know so that you can get started with this new way of thinking. Okay, so let's look at some dynamic array formulas. As I said a few moments ago, there are new functions that make use of this new spilling functionality. I won't go into detail about each of them here because we'll have future videos on each of them. But the critical thing to realise is that the ability to spill is not restricted to those new functions. Many existing functions spill too. So let's have a look at an example. This is a simple scenario in which we have data in cells B2 to C9, and the data displays a name and a score for each person. Let's assume the goal is to calculate the total for each person. So if we don't have dynamic arrays, this is how we would tackle this problem. We could use the SUMIFS function. So I would type equals SUMIFS, open bracket. The first argument is the sum range. So I want to sum the cells, C2 to C9, comma, the criteria range, will be the cells B2 to B9, and then the criteria is where it equals the cell there, Tom, so E2. Now close that bracket and press return. And it would calculate a single result. Now if I wanted to see the result for Tom, Dave, Jack and Billy, I could select that cell. I could put some dollars on those by pressing F4 just to lock in those ranges, drag that down. And as you can see, we would then get a result for each SUMIFS function. We've got 4 formulas and 4 cells. But wait, if we have Excel's new calculation engine with dynamic arrays enabled, we don't need this at all. Let's clear out those cells. This first formula, we can select E2 and we can drag that down. Now if you remember back to our original example when we had cells B2 to B6, with dynamic arrays what happened is that it calculated all those results and it spilled them out into the cells below. Well, guess what? I'll press enter and it's going to do exactly the same thing. So rather than having 4 formulas and 1 cell for each, we can have 1 formula that returns the results into 4 cells. Okay, so we've seen SUMIFS, and we've seen that SUMIFS spills if the last argument is provided with a range or an array. So which formulas spill and which ones don't? Well, it depends on the arguments that are required for each function. So basic aggregation functions like sum, average, min, max, well, they don't tend to spill by themselves, which makes sense because they accept a range of values and they only ever return a single value. Instead, the general rule is that any function that contains an argument in which a single value is expected, that function is likely to spill. Now that single value has a technical term. It's known as a scalar. Let's take a look at another example. Let's use VLOOKUP because it's probably a function that we're all familiar with. The first argument in VLOOKUP is the value to look up. It's generally a single value, so it's a scalar. If we provide two or more values in that argument, the formula will spill and calculate the results for each of the items provided in the lookup value. Okay, so let's have a go with this. Here I'm going to type Dave and also Jack. And then in cell F7, I'm going to type equals VLOOKUP, open bracket. And for the lookup value, I'm going to provide not a single lookup value, but two. I'm going to provide the cells Dave and Jack, so E7 and E8, comma, my table array, I can select those cells up there, E2 to F5, column index will be 2, and I want an exact match, so 0, close that bracket, and when I press return, as you can see, VLOOKUP will also spill the results for multiple cells. So one function has given us the result for Dave and Jack. So there we have it. That's the general rule that we're working with. That any time that we provide multiple scalars, that formula will spill. But that's not always true, depending on the complexity of the function that you're using. The thing is, we're all still getting used to this new way of thinking about Excel formulas. And I'm sure that over time, new ways of thinking about formulas and functions will develop. Now let's move on to think about spilling for a few minutes. By clicking on any formula that spills, what we'll see is that there's a blue box that highlights the area that is the spill range. Everything within that blue box is calculated by the top left cell of that box. Now I can select other cells within that spill range. So if I select the second cell in the spill range, have a look at the formula bar. When I click that, you'll see that the formula turns grey. And that's because I can't edit the formula in that cell because the formula doesn't exist in that cell. The formula is always in the top left. But if I do select that first cell, yes, I can edit it there. The formula bar has turned black and I can now edit that function. Now you might be thinking, what happens if I already have some values in the cells that the spill range is trying to occupy? Well, let's assume that we have something that's in the way. And as you can see here, it's picked up our VLOOKUP, let's just clear that. So we've got something that's in the way and we get to see the new spill error. By clicking on the spill error, we get to see, rather than a solid blue line, a dotted blue line. And that's highlighting the area that formula would spill into. However, we've got an issue. We've got something that's in the way. And then it becomes your choice. You can either move the formula or you can move the thing that's in the way. So let's just delete that. And as you can see, that then spills again to fill the space that it wanted to fill before. Now the spill error can occur in several situations. It can happen where the spill range is outside the available cells of the worksheet, or if the spill range has an unknown size. The spill error also occurs if you try and use a dynamic array formula inside an Excel table, or if the spill range contains a merged cell. It can also happen if the spill range is so large that Excel runs out of memory. As formulas can spill results into other cells, we now need a new way of referencing the cells of that spill range. Well, thankfully Microsoft has already thought of this and has created a new referencing methodology for us to use, and it involves the hash or the pound symbol depending on what country you're from and how you might refer to it. So here in our example, the top left cell in the spill range is cell F2. So we could reference that entire range by using F2 hash or F2 pound symbol. So here I could type equals, click F2, press the hash key. There we have it. And it's now referenced all the cells that is filled by the spill range that starts in F2. And we can also use this inside existing functions. So for example, if I wanted to find the average score, average, I could type equals average function. I can press F2, press hash, close that, and as you can see, F2 hash has already filled the full range of cells there. If I press return, it'll then calculate the average of all of those cells. Okay, now let's move on to think about constant arrays. Constant arrays have always existed in Excel. However, given the introduction of dynamic arrays, the use of constant arrays is likely to significantly increase. And let's turn to VLOOKUP again. So in cell G3, if I were to type equals VLOOKUP, open bracket, and I select Tom, so just a single scalar, and my table array is going to be from B3 down to D6. Now normally we would provide a single column index number. However, in this circumstance we can actually provide a constant array. So I'm going to put a curly bracket and then enter 2, 3 curly bracket, and I want an exact match, and I'll close that and I'm going to press enter. And as you can see, for Tom it's returned the values of 74 and 67, and that's because this formula includes a constant array. So let's look at this formula again, and here you can see in the curly brackets the 2 and the 3. That means that Excel is using both values, a column index of 2 and a column index of 3, and is returning calculation for both of those into cell G3 and H3. Using the old method, we would have required 2 formulas, or maybe selecting those cells and pressing Ctrl-Shift-Enter. But now, just by using a constant array, it will automatically spill those results into the other cells. You see, constant arrays aren't actually that complicated, they just sound complicated. Now just one thing to be aware of, columns are separated by commas and rows are separated by semicolons. So if we wanted to spill the results into rows instead of across the columns, we would use a semicolon instead of a comma. So let's try that. Let's take out that comma, enter a semicolon, press return, and as you can see, those results now spill downwards. What happens if we want Excel to operate in the old way, the same way that it always did? So let's head back to our original worksheet. Now we know that if we type equals B2 to B6, it will spill those results in that range. But if we want to use implicit intersection, all we have to do is use the @ symbol. So there we go, equals at B2 to B6, and we can press return, and Excel is now using implicit intersection. So if we were to copy that down, we'd get the 3 as we had before originally, and if we paste it in there, we'll also see the hash value error, because Excel is operating the way it did before we had dynamic arrays. To ensure that formulas built in previous versions of Excel continue to calculate the same result, the @ symbol will be added to a lot of formulas automatically when they've been created in previous versions of Excel and opened in a new dynamic array version of Excel. And this means that workbooks created in old versions of Excel should never spill. They should still calculate the same results as they always did. Now, that doesn't mean that the new dynamic array functions that we'll look at in the next few videos exist in previous versions of Excel. They don't. If you try and use one of those, you'll get a hash name error. However, it does mean that if we try and use an existing function that works in both the traditional version of Excel and a dynamic array enabled version of Excel, that function will still work on both versions. I'm sure you've now got 100 questions spinning around your mind about dynamic arrays, and there's lots of new terminology and lots of new ways of working in here. And while the changes may seem confusing initially, you'll soon see this brings new powers to Excel users, which makes Excel much easier to use. I hope you'll hang around for the next video when we'll start to look in more detail about dynamic arrays, and specifically some of the new dynamic array functions that were introduced specifically to make use of this new methodology. Okay, that's it from me. If you like this video, don't forget to subscribe, like and comment, and I'll catch you next time.